All right, so we're going to be in section 3.3 in this video, beginning to talk about slope. And so I always tell students every semester that of all the things that we study in this class, slope is probably my favorite because it is so applicable to so many different areas of real world, just real life. And so as we talk through this, I'm going to show you some examples from an algebraic standpoint, but also want to kind of connect it back to a real world aspect too, just so you see how much slope can be used. And so one of the first places that I think about slope is when we think about any kind of line, any kind of hill, any kind of thing that has steepness. We're going to be talking specifically about lines, but you can think of anything that's got some type of steepness. You may say, oh, well, that hill's really steep, or that mountain is really steep, or that rooftop is really steep. And all of those things have a steepness. And so we measure the steepness, really steep, not very steep. We measure that with a measurement that we call slope. And so if you think about, the roof line of a house, think about your house and the roof line. Well, it could be really steep or it could be not very steep at all. And so we can actually put a number on that. We can actually measure that. And so when we measure slope, what we're really measuring is a vertical change, so an up and down change, compared to a horizontal change, right and left. Okay, so think about this. We're wanting to know how far something goes up or down vertically, and then also how much it goes right or left horizontally. So, for example, if you were going to build a house, my wife and I built a house about 5 years ago or so, and when we built our house, my builder comes to me and he says, what do you want the pitch of your roof to be? Now, understand, pitch and slope are the same thing. And I said, well, I don't know. What are my options? And he said, well, you can do what your house plans say. And he said, or you can make the pitch smaller, but he said it's going to be probably a little less expensive, but it's going to make your house look smaller. Or you can actually do it bigger, which is going to make your house look bigger, but it's going to be more expensive. And so we were able to talk about it and decide what we wanted. And so I had to assume that my builder knew something about slope. Because if, just as a very simple example, if this represents my house, if he were to put my roof on my house and it looked like that, well, then I got a problem, right? So when he was talking about slope, what he really wanted to know was how high do you want it to go vertically? And then he was going to measure how far it needed to go horizontally, and then the roof would have a specific slope, and then he could do the same thing to the other side. And so if I wanted it to be smaller than my house plans, then it wouldn't have gone as high, and so you might have a roof line kind of like that. Or if I wanted it to go higher than my house plans, then you could have something like this. And so you can kind of picture that. Buildings that are usually really, really big, and you think, oh, wow, that's a really nice building. A lot of times they have a really steep roof, and that steepness makes it appear bigger. And so when he came to me and talked to me about the slope of my roof, or the pitch of my roof, I had to assume he knew something about slope. And so what we're going to talk about today is how to find the slope, and what slope is, and some of those things. And so you need to understand that slope is simply a vertical change compared to a horizontal change. That's what this definition says. So in other words, it is how much something changes vertically compared to how much it changes horizontally. Okay, so that's what slope actually tells us. And then that gives us the steepness of this line. And so what we refer to that as, or we refer to that as rise over run. You've heard that probably before in an algebra class, rise over run. Rise being your up and down, how much our line changes vertically. The run is right and left, how much it changes horizontally. And so you need to understand that slope is simply a ratio. It is a way to compare two things. For example, when I used to teach at the high school level, I would take my students to the football field, and I would have them in groups of 3 to 4 people. And I would have one person that would run 40 yards, sprint 40 yards. I had one person that would jog 40 yards and one person that would walk 40 yards. And so what we would do is we would take their information and we would come back to the classroom and we would make 3 different graphs. And so you'd have the graph where they would run, the one where they would jog, and the one where they walked. Now, when we were doing this, we would compare distance to time. So distance being 40 yards for each of these. And then our time was done in seconds. And so we would have our seconds written out across here. And again, this is just going to be a sketch just to illustrate this to you. But when we would go do this activity, a lot of times the better athletes in the class would want to show how fast they were. And one time I had a guy run a 4.540. Now, it's 4.5 seconds to go 40 yards. So his graph sort of looks something like this, where he traveled this 40 yards. So he traveled 40 yards in 4.5 seconds. Okay, gave him that line. But then the person that would jog, their line would look kind of like this, where they would still travel that same 40 yards, but now it may take 8, 10 seconds, something like that. And then for the person that would walk, theirs one time looked kind of like this. I had somebody take over a minute one time to walk 40 yards, and they never stopped. They took just very slow steps. Anyway, it was quite painful, but it did give us really good information, because now when you look at those 3 graphs, it's easy to see that as the speed changes, as it gets faster, the line gets steeper. You can see that here. And as the speed slows, like in the last graph, then that line is not as steep. It begins to level off some. And so when we talk about the slope, we're just simply comparing two things. So we talk about speed a lot because that's an easy way to compare two different things. Because when you talk about your speed, if you were to say, well, I traveled to, from my house to school or from my house to pick a place, if you were going to tell somebody how fast you went, you would say, well, I went so many miles per hour. Miles being your distance. In this case, that's, In this case, that's the vertical. And then you would say miles per hour, hour being your time. And so when we talk about speed, we talk about miles per hour, meters per second, feet per second, yards per second, kilometers per hour. You can talk about speed, and we always compare distance to time. And so we need to understand that's all slope is. And so we can use slope in a real world situation to be able to look at speed, graphically be able to look at it. We can look at a number of different things that we're trying to compare by looking at the slope. And so we could go into a lot of other situations and talk about that. We're not going to do that today. But I want you to understand slope is very applicable to a lot of different things that we're going to talk about. And a lot of different things in the real world as well. Now, I skipped this point, the second point there. When you look at a graph from left to right, if it slants up, we're going to mention this in a few minutes, that is going to have what we consider to be a positive slope. If it slants down, as you look at it from left to right, it's what we consider to be a negative slope. So that's going to be important. We'll come back and talk more about that in just a few minutes. And so what I want us to do here is I want us to find the slope. And we really have three ways to do this. We can literally look at the graph and count rise over run. We're going to have a slope formula that we'll talk about in a few minutes. And then we also can use equations to find the slope. And so when we look at the graph, we're looking at, in this case, these 2 points. And we want to figure out what is the slope of this line. Now, one thing you need to understand is that the slope is going to be consistent. So if you can find the slope of part of the line, that's the slope for the whole line. Okay, because the line doesn't have curves and doesn't twist and turn and do all these different things, it is a straight path. Whatever the slope of part of it is going to be the slope for the whole thing. So the way we're going to find this is we're literally going to count rise over the run. Rise being our vertical change, run being our horizontal change. And so when we do this, we're always going to start with the point to the left. So in this case, it's this point. And we're either going to count up or down. If we count up, it's positive. If we count down, it's negative. And then we're always going to go to the right. Now, I have people ask all the time, well, can't you go left? And the answer to that is yes, you can technically. We're not going to for this class. I think it saves you some confusion to always know go up or down and then always right. If you'll do that, then you don't miss a sign or have any kind of issues that come up with signs. So in this case, if we're going to count rise over run, we're starting at the point that I have circled. And so we're going to go up 1 unit, 2 units, 3 units. So our rise is positive 3. And then we're going to run to the right 1 unit, 2 units. And so we would say, well, our slope here has to be 3 over 2, meaning that for every 3 units we go up, we go right 2 units, and we're on this line. And so we should be able to do that again from the second point. If you were to go up 1, 2, 3, and right 1, 2, well, you would see that this point is also on that line. And you could even do that again. Go up 1, 2, 3, and right 1, 2, and you would have another point that's on that line, assuming that you were to extend it out. And so this is a way that we can find a number of different points that fall on that line. And so remember in section 3.1 we talked about how these points that are on this line are solutions to an equation. Well, right now we don't know what the equation is, but we know that if we want to find a solution to it, if we go up 3 and right 2 for this particular line, there's going to be another solution. And that will be a whole number solution, which is going to be really, really helpful for us. So what I'd like you to do is, using this point and this point, take just a minute, pause the video, find the slope of this line. So I'll give you about 3 seconds to pause the video, and then I'll do it for us. Okay, so hopefully you paused the video, you quickly found the slope. Again, when we count rise over run, we are finding just that. Rise, and then we're going to find the run. And then that fraction, again, that comparison is going to give us what we're looking for. So, in this case, again, starting with the point to your left. So as you watch this, the point that's on your left-hand side, which in this case is this one, that's where we start. And then we're going to go up or down. And so in this case, to get to the other point, you're going to have to go down. And so we go down 1 unit, 2 units, 3 units, 4 units. And so our rise is a -4. Now, I know that the word rise makes you think going up. But because we're always going right, it is possible that our rise could be that we go down. Okay? So just be aware of that. We're still calling it a rise, even though we might go down. Now, from that point, we're going to run 1 unit, 2 units. And so our fraction here is -4 over 2. Now, if that will simplify, you must simplify. In this case, it does. We know it simplifies to -2. And so with fractions, or with slope, fractions are really good because it tells us rise and run. So we're not going to rewrite this as negative 2 over 1. But if you were to think about, well, what's the rise and what's the run, that's what it is. It's negative 2 units down, 1 unit right. We're going to write it this way as just negative 2, but understand that it is still a fraction. So why does that matter? Well, if we start at this original point, because our slope is negative 2, we could go down 2 units, so 1, 2, and right 1, and we would get this point. Well, that point's on our line. That's good. That's what we wanted. And then again, you could go down 1, 2, and right 1, and you would be at this third point. And so once we find the slope and we simplify that, that's going to tell us how much we need to go up or down and how much right to get another point on that line. In this case, we're strictly looking for the slope. It is negative 2. If you have any questions about that, feel free to email me and let me know. So, with that in mind, let's move over to the slope formula. So our slope formula is always going to be notated by a lowercase m. That's important. You need to make sure you understand we always use a lowercase m to represent slope. And we have this slope formula that can be used if I give you a set of ordered pairs. If I give you the line, you can just count rise over run. But if I give you a set of ordered pairs, you may not want to have to try to graph those and then count. And so this formula is going to allow us to do that without ever having to actually look at a graph. So what the formula says that we're going to find the change in our y value. Again, that's your up and down change. That's your vertical change. And we're going to compare that to our change in our x value, which is the right and left change, horizontal change. And so it's exactly what we talked about a few minutes ago, the rise and run. But we're looking at it from the standpoint of being ordered pairs. Okay, so be aware of that. Now, as we look at this one, you'll notice that our formula says that we're going to take y sub 2 minus y sub 1 and divide it by x sub 2 minus x sub 1. Again, that y sub 2 minus y sub 1 on the top is our change in our y value, how much it changes vertically. And then our change in x value is x sub 2 minus x sub 1. And so if we can put in our numbers into that formula, then hopefully it's not going to be a huge deal to find the slope. So you need to understand that when you find the slope, looking at this first example, I'm going to give you two ordered pairs. The first ordered pair is an x and a y, and the second ordered pair is an x and a y. The 1s and 2s from our formula mean first point, second point. So our 1s are going to be from the first point order pair. The 2s are with the second order pair. Now, it doesn't really matter if you happen to switch those up and you did the 3, 4 first or the 4, negative 1 first, but that is what the 1 and 2 means. So, if we're going to use our slope formula, it says we're going to take y sub 2, which is 4, minus y sub 1, which is negative 1. So notice what I did there. I said 4 minus, and then look to see what is this number. And it is negative 1, so it's minus negative 1, which we'll simplify in a second. A lot of people end up making a mistake, and they say 4 minus 1. Well, 4 minus 1 and 4 minus negative 1 are two different things. So you got to make sure you have the right number there, so be careful with that sign. And then on the bottom, x sub 2 is 3 minus x sub 1, which is 4. And so now we should be able to simplify that. So this minus a negative does make that become positive. So that 1 become positive. So 4 plus 1 is 5. And then 3 minus 4 is negative 1, which is going to give us negative 5. Now, finding the slope is great. But I think, in my opinion, it is a really good practice to begin to think about what does this slope mean? And being able to, in your mind, kind of get a mental picture of when I say this line has a slope of -5, you should be able to, at kind of in your mind, picture what that line's going to look like. And so when we look at this one, for example, this slope of -5 means that if we have some point on this line that we're talking about, for every 5 units that we go down, because it's negative, and then right 1 unit, because remember, -5 is the same thing as -5/1. For every 5 units we go down and then right 1 unit, we should have another point on that line. So our mental picture then sort of looks like this, where we have, sorry, that keeps moving. If you go down 1, 2, 3, 4, 5, and then right 1, well, we're going to have a line that looks something like this from a steepness standpoint. And so I'm not going to necessarily ask you to give me that sketch, but I think it is a good habit to get into so that you begin to develop this mental picture. Because when I tell you later on that an equation is an equation of a line that has a slope of -2, well, in your mind, you need to think, okay, here's what that graph's going to look like. And if you can picture what it looks like, then when we graph with slope later on, it's really, really easy. So let's look at the next one. Again, we're going to find the slope. So our slope formula says we're going to take y sub 2, which is -9, minus y sub 1, which is 7, and divide that by x sub 2, which is -5, minus 3, because that's our x sub 1. And as you simplify that, -9 minus 7 is -16, and -5 minus 3 is -8. And then -16 divided by -8 is a +2. Now, again, from a mental standpoint, what does that look like? Well, it means that if we have some point on this line, for every 2 units that we go up and right 1 unit, we should have another point on that line. And so your graph then looks something like that. And again, I'm asking for the slope, but I do want you to begin to get this mental picture. And then, if you look at the last one, you may want to pause the video here, try this one on your own. If we were doing this in class, I would ask you to do that. So if you want to pause it, give you 3 seconds. All right, so if you do this one, we are going to again follow the same formula. We're going to take 9 minus 4 over 7 minus 2. Well, 9 minus 4 is 5. 7 minus 2 is also 5. 5 over 5 is 1. Now, again, from a mental standpoint, what does that look like? Well, it means that if we have a point on this line, for every 1 unit that we go up and right 1 unit, we're going to have another point on the line. And so our line's going to look something like that. Now, I would encourage you as you look at this, first of all, let me ask this question for you to think about. Which line is steepest? So hopefully you look at those 3 lines and you go, oh, well, the -5, the first one. And that's true. That one is steeper than the others. And that should make some sense because its vertical change is greater. It changes more up and down before it ever changes to the right. And so because of that, you have a steeper line. Where with this last one, well, for every 1 unit you go up, you're going to go right a unit. And you could continue to do that. And so the vertical change doesn't happen very much before the horizontal change happens. Where with this first one, the vertical change, you have to move 5 units before you ever move over any. And so hopefully that makes some sense. Now, also notice that as you look at each of these graphs from left to right, if the graph goes down from left to right, then it is considered to be a negative. So this first one is -5. You notice that it goes down as you look at it from left to right. The other two are positive slopes. They go up as you look at them from left to right. And so as we talk about graphing later on with slope, if you graph a line that has a positive slope and it happens to go down as you look at it from left to right, then you know you've got a problem. Automatically, there's an issue, and so that line should always go up if it is a positive slope. Again, negative slopes are going to go down.